Up to this point, we've seen physics and how it works generally in Unity, and in this video we want to take a look at how we set up physics joints between physics bodies. So what exactly is a physics joint? Well, first of all, a physics joint is simply a constraint. So it's a constraint that determines the position or the movement of one physics body in relation possibly to another or to a point in the scene. And these can give you the ability to connect physics bodies together. So imagine you were trying to simulate the way a car moves or some kind of object with articulated joints. Well, you would do that through these joint objects. So let's start with a little bit of setup. I'm going to go ahead and create a couple of sprites here. And for the sprite, I'm going to use my blue and red texture. And let me zoom in here a little bit. And this is just going to allow me simply to create and to see exactly, where the edges are, and especially if these things rotate. Now I'm going to just create some walls here, and I'm creating them on the edge of my camera just so I know, exactly what's going to be drawn. And I also, if you notice, I clicked on my camera just to see what it could see, and I realized immediately that my sprite's at a position that I can't see, so I need to move this here to the Z position. And now if I go back to my camera, I can see that this blue and red box is on the bottom. Right now it doesn't do anything, so I'm going to go ahead and add a component, and I'm going to put a box collider 2D on it. And this will keep, if you remember, this makes a object have a collider that will interact with other physics objects, but it'll be a static object, so it won't be able to move by the physics engine, and it's not expecting really to be updated. So we sort of expect this to be still. I'm going to take this and I'll just call this bottom wall. Then I'll just duplicate this and I'll call this left wall. And I will grab this. Whoops. Let's just grab this, and then we're going to rotate it around the Z-axis by 90 degrees. And then I'll just grab it and drag it here, something like that. And then I'll do the same thing again. I will just duplicate this, and I will call this right wall. And then quickly move this over so that's in my scene like this. So now if I look at my camera, I can see that my walls are there. Of course, we want something that's going to bounce around in here, so I'm just going to go ahead and add, we'll just call it a ball or something like that. So I'll say sprite, and then I'll use my planet sprite that we've used like a million times. And you can see it right there, little tiny thing. On this, I'm going to add a component. It's going to be a circle collider 2D. And I'm also going to add a rigid body. So rigid body 2D. This will allow it to bounce around. So this should give me, basic physics. Let me just call this bouncing ball. All right, so that gives me my bouncing ball. We're almost done with our setup. I'm going to maybe make this a little bit bigger because if I were to play it right now, you'll see that it works, but it's going to be pretty tiny. And we noticed we didn't see anything there, so let's get everything set up in the right locations and everything like that. So if I look at this, 90, look at this is also in the wrong position, so I'm going to put this at 0 so we can see it. And yep, looks pretty good so far. All right, and then I'm going to add another ball to this bouncing ball. So this has a circle collider. One of the things is it's not going to be very bouncy, so what I want to do is add a physics material to it. So I'm going to do that really quick by creating a 2D physics material here, and I'll just call this bouncy. And I'm going to crank the bounciness up to about 0.8. And then from here, I can take this and drag it to my various objects. Probably should have done this first. It would have saved me a little bit of time. But then this will allow my objects to sort of bounce off of each other a little bit better than they did before. And just to make sure, yep, got them all. So we'll just save our scene like that. This is the beginning of our scene. Oh, and I wanted to make this bouncing ball just slightly bigger. So let me zoom in, and we will just scale it up a little bit. Something like that. so that then, I'll be able to see the ball as it bounces around. Okay. You can see it bouncing there. So one thing I noticed was that the game window is not showing exactly what the camera is. If I look at my camera here, I can see that that's what my camera should be showing. And the reason is that if you ever have this happen to you in your game window, you can come over to here and you'll see that there's a scale slider. And it's because it's not set properly. It's kind of scaled in too much. It allows you to sort of magnify your game. So I'm going to just drag this out, and then we'll see if we can see my whole scene. That way, I'm looking at exactly what my canvas sees. So now that we have this, what I'd like to do is add a second ball, and I'm going to call this, I'm going to just duplicate this. We'll call this kinematic ball. We'll create a kinematic object. I'm going to use a different icon for this. So this planet sphere. All right. And then I will move this a little bit. Let me go back to my scene here so I can actually move it over, and you can see, okay, it's in a different position here. All right, so what I'm going to do is add a script to this, and I don't, if I look at this Rigidbody, I'm going to tell it that it's going to be kinematic. This also has a circle collider on it, exactly as expected, and then I'm going to go ahead and add a script, and we will call this, we'll just call it the same thing, kinematic ball. And we'll create and add this. Now, what we want to do is be able to move the ball around sort of wherever the mouse is, and then if we hit things with this, it should apply some force to those objects that we hit. Now, it's not going to be perfect because I'm not moving the ball with forces, so I'm going to just sort of fake how it would normally work. Otherwise, I'd have to, do some kind of calculation to figure out how I'm going to move the ball with a force, sort of like you would, with a cue ball in a pool table. Or billiards, you would hit it and you would let the physics engine resolve all those collisions. Well, here, because I'm moving it with a script, it's not going to have that movement set up automatically. So I'm going to apply forces whenever I have a collision in this case. Okay, so here we have my script. Let's go ahead and open that. And let's add a few things to it so that we can see what's going on. First of all, the mouse position, from the game engine is returned as a vector 3. So let's just take a look at that. It's nice to sort of see what values it's giving us. So we'll just call this mouse position. And then we want to keep track of the last position we were in between frames. So we'll call this last position. And the idea here is that we're going to calculate a vector between the previous position, the mouse position, and the last position to know, really the mouse position in world coordinates and the last position to know, how fast it's moved between frames. And then that we're going to use it as a vector that we can scale up. And so what I really want to do is make a scale value. And then we want to see what that vector looks like. And we'll just call this velocity. Now, one thing that you might want to do that's often done in game engines is that you want to keep track of an object and not have to call get component all the time, because it takes a bit of time to find that component on your object. So even though it's not a lot of time, it's common to do this. The main reason you want to think about if it's worth doing this or not is if this can change. So if you have a camera, I'm going to keep track of my camera. I guess that's what I should have said first. This is going to be a var to keep track of camera. And the reason is that I only have one camera in my scene, so it's not going to change. I don't have to worry about this somehow giving me a wrong value after I calculate it the first time. And I'm going to just say something like this. Game object equals game object find with tag main camera. And the main camera in Unity by default always gets this tag. It just sets it up in your scene with this tag. So you can always find it like that. I mean, you can also do camera.main like this, and it kind of does all the same thing, but it's useful just to see what's going on. And then, just to make sure you didn't accidentally do something like delete your camera out of your scene, it's good to be able to log information about it. So I'm just going to say cam equals object get component, and this is the camera. So the important thing to understand is that your camera is just another game object, and it has a special camera component on it. And then if this doesn't work, you want to make sure to log something, so to catch, the error, so log error, and we will say unable to find camera. So if you see this log message, then you know that there's an issue. All right, so that is just to set up our camera because we're going to use it. And instead of doing this in update, I'm going to do fixed update like this. And if you notice, it filled it out for me. So private void fixed update. And then I can say last position. The first thing I want to do is just store whatever the last position was. So I can say last position was mouse position. And actually, I don't want to say the mouse position. See, if I just use the mouse position that it gives me, like I can't just use that position unless this mouse position is always in world coordinates. So when I'm getting this mouse position, what I'm going to say is mouse position equals camera. So I'm going to use the camera, and the camera has a screen to world point function. You've seen us use this before when we were doing object picking, and I'm going to say input mouse position here. So this will give me the mouse position in world coordinates. So store the last mouse position. Let's leave some comments for ourselves and grab the current mouse position in world coordinates. And then we're going to calculate the velocity. So velocity, if I can type it right, is equal to mouse position minus last position. And then we're going to scale it by whatever our scaling factor is. And then the last thing we're going to do is say transform.position. So let me just leave a little note here really quick. So velocity from the vector between these points. All right. So the last thing we're going to do is we're going to set the position of this actual object to be the mouse position. All right, but there's one issue in that the mouse position, the z coordinate, is going to be whatever my camera coordinate is. So I don't want it to just be this, actually. What I want to say is new vector 3, mouse position x, mouse position y, 0. And I could even do something like this, transform position.z. You've seen me do this before, so it's not something new. But just to remind you, we want to keep the z coordinate and use the x, y coordinate of the mouse. And this, if you look at the mount of this object over here, that you can kind of see the left, right, the center is where its position is located. So in essence, wherever I have my mouse, this object is now going to hover over that position based on, where the mouse is going. So it's going to set its position to be that. There's one more thing that we want to do, and that is that we want to deal with collision. So on collision, enter 2D. When we do this, it's going to give us this object. So we can just now say, basically what we're going to do is apply the velocity to the other object. And that's what this collision gives us here, right? This collision gives us information about this other thing. So I can just say collision, rigid body. I don't actually want that. I want other rigid body. Okay. Velocity plus equals velocity. And so what I'm doing is I'm just, whatever I calculated the difference between, the previous frame and the current frame, whatever that vector is, I'm going to add that to the velocity of whatever rigid body I run into. So this will just give us some ability to mess with the objects in our scene. And we're going to use this setup for the next set of videos. We're going to kind of go through the different joints and see how they're affected by these objects. But just to give you an idea of what this looks like, let's go back to our kinematic ball. You'll notice that we have now our objects here, our last position and everything. These obviously aren't updating because the game's not running, but I'm going to set my scale to 10. And then we can run this. Take a look. And then you can see we can kind of mess with this ball. And I may have knocked it out. I don't know. Looks like I did. So, but it gives you that ability to just move this object around so that it's wherever my mouse is located. Okay. And the other thing to notice is that it is a kinematic object. So you remember these are colliders. Well, because it's a kinematic object, I can push it through anything that I want to. So something to remember when you set something to kinematic, especially if you do it to your main character, you'll be able to just shove that sucker right through anything. Okay, so now that we have this initial setup, let's just back up a little bit. I'm going to make my camera frame, maybe I'll make my camera just slightly bigger. There we go. And I'm going to add a new object to it. It's going to be just a 2D sprite. Well, actually, I'll just take this, say let's take this wall right here, and we will duplicate it. It may be slightly easier. We will call this platform. Then I'll take it and I'll move it, and I'm going to shrink it by doing this, and maybe I shrink it down a little bit like this so it's a little bit flatter. Let's get a little bit closer. And what I want it to do is to be able to interact with this object here. Well, if I just hit play right now, like all it's going to do is just bounce on this object, or at least hit it and not do much. Okay. But the point is that we want to turn this into a joint. So let's do that next. So the first kind of joint that we're going to look at is called a distance joint. And in order to do that, we're going to add a component. And if you just type joint 2D, then you'll get all the 2D joints. All right. So the first one is a distance joint. You'll notice that it immediately adds a rigid body to this object. So this rigid body is going to make physics act on this object. So remember, a joint is a constraint between the physics object and something else. And so we want this object to be dynamic so it can be moved around, but fulfill the requirements of the joint. The thing to notice on the joint is that there are a couple of things. One is enable collision. Enable collision just basically says that, if you can imagine the joint possibly being like a bar or something to that effect, is it something that the other physics objects can collide with, so maybe they can't pass through it. You would set this if you wanted that to be true. If you have connected rigid body set to none, then what it's supposed to do is set the sort of the anchor point to be the scene. So whatever position this is on, the anchor point is going to be that value. If you have auto configure connected anchor, then if you connect it to something, it's going to help set up all of these values. And then the main thing that's going on here, auto configure distance, is it's just calculating the distance between the center of this joint, which is at the center of the object, and over here. Now I can of course take these and move these, but just to point out, this is the distance here, which makes sense, right? That's the square root of this square right here. So let's hit play and see what it does. And what distance is going to do is it is going to maintain a distance from wherever it's connected, a certain distance. So this 1.41 value is the distance that it's going to have. So you can see now, it is, freely rotating around that point, but always making sure it's within a certain distance of that. Now the object itself at the anchor point, like where it's connected on the object itself, can also spin with a distance constraint. And so this allows it to, rotate also while rotating around that joint. And this gives you this behavior that you see here. Now let's turn off the screen snapping because I want to move this joint in other places that's not on the grid mark. And I'm just going to move it randomly to here. It would probably be useful to put another sprite on there so we can see where it's rotating around. So again, put a sprite. Again, my favorite thing is to use Street Fighter things in here, is to use another object. So let's use a smaller scale one. And we'll just use that one right there. and we will call this anchor. Right, so if we come back to here, we can see that this is what I want to do is just put my anchor, my object, right on that point here. And then you can just to make it clear that we're keeping this distance here solid so that we're not getting smaller or farther away. Oops, and of course we can't see it. I just realized because of course I put my sprite and my anchor in the wrong location. So let's fix that really quick. And then here we can see, you know, we're always going to be like right solid around this point here. So that is the center of our rotation that we're seeing. Okay. So that is a distance joint, and you can see that it could be useful for connecting objects. You could have, of course, constrained these other objects, right? So this platform, if I didn't want it to rotate, well, then I can come to its rigid body and I can say, well, freeze the rotation around Z, right? And if I do that and come back over here, we're frozen in this, and then I could force it to rotate in a particular direction if I wanted to. All right. I could also say freeze X direction, and if I do that, you'll see that my constraint is going to be so solid that there's not really much I can do. Okay. Now, one thing that's interesting about this, right, there are, of course, you know, multiple positions, but what the physics engine is trying to do is resolve the collision that's happening here. So it's doing it by applying forces to your object. This may be not what you expect. I mean, it seems like I could just calculate it, but in order to maintain this proper distance, if I've moved my object somehow because I've applied some big force to it, then the physics engine will apply a force to try to get it to maintain this constraint. And that's why we see some weird behavior with it bouncing around. And then on top of that, if you look at that, the joint itself, what you'll see is there's a brake force here. So if the force gets too high, the joint can break. And this allows you to, I guess if it's just too heavy, there's too much mass, this allows you to set up the system so that, you know, if there's too much stretch, like you had a spring or something, then it would actually break, and then your object would fall apart. The last thing we want to talk about with this distance joint is the connected rigid body. And as you see, it's set to none right now, which means that it's connected to the scene. And instead, we want to connect it to our anchor. Now, before we can do that, you'll notice that this rigid body, it says it's asking which connected rigid body is it attached to. So if our anchor itself has nothing attached to it as a component, and so we want to add a rigid body here. So we're going to put that rigid body on there. And then because it's a rigid body, if we don't put any collider on it, it's just going to pass through everything. So let's go ahead and add a collider to it. Circle collider. And then I'm going to make this static initially, and then we'll see what happens when we change it to dynamic. So then we can come back to our platform, and we can come over to our distance joint. We can grab our anchor, and we can attach it to the rigid body here, and we'll see that it's now attached. Now, this anchor point is in a really weird location off of this object because it's a physics engine, and so it doesn't really care what the image is that's being drawn, even though it's incorrect, because the collider, you know, only is around this area. It's going to constrain it from this distance to the object. So we want to grab the anchor point and actually put it on the object, which would make a lot more sense, so that now these two are attached. And when we hit play, we'll see that the behavior is going to look almost identical, except that we can, you know, move this around. But if we take the anchor, and now instead of being static, we decide that it's dynamic, we'll see that the whole thing falls. And now you get a good feeling for there being this solid connection between the two physics objects, because, you know, they're connected together and it's constraining it. I may have shot this out of my system, so let's put it back really quick. You know, it's constraining it to make sure that it fits the distance that's being required by the physics joint. So let's go back here and put it dynamic, and then we'll get some nice behavior. Okay, and it stays within our little playground here. All right, so that should, you know, give you a good idea of how these joints work for the distance joint in particular, and we will be back with other videos on the other joints.